Hello students, welcome to Engineers Academy. Do hit the subscribe button if you are here for the first time. Now we are going to solve this problem which says that the two structural members, one of which is in tension and the other is in compression, exert the indicated force on joint O, determine the magnitude of the resultant R of the two forces and the angle theta which R makes with the positive x-axis. So we are given this structure in which one of this member is in tension and this member is in compression, and we are asked to find the resultant of both of these forces. So the 2 kilonewton force is acting along this line of action and it is making 30° with the positive x-axis, or we can say with the horizontal, and this 3 kilonewton force is also acting at that point O, and the direction of this 3 kilonewton force, or we can say that the angle of this 3 kilonewton force with the horizontal, is given in the shape of this right angle triangle. So first of all, if we find the hypotenuse of this triangle, so we can always apply the Pythagoras theorem. So the hypotenuse of this triangle will be equal to 3 square plus 4 square under the square root, and that is equal to 5. So you guys can see that 3 square plus 4 square under the square root is 5. So the hypotenuse of this triangle is 5. So let me write that the hypotenuse of this small triangle is 5. Now we are asked to find the resultant. So the resultant vector will be equal to Rx, the x component of the resultant in the I direction, and we can say plus Ry in the j direction. And we can say that the Rx vector will be equal to the sum of the x components. So the sum of the x component of both the forces. So we can say that the sum of the components in the x, and we can say that the sum of the x component of the 2 kilonewton force and the x component of the 3 kilonewton force. So I can say, let's say that this 2 kilonewton force is, let's say, F1, and this 3 kilonewton force is, let's say, F2. So we can say that this will be the sum of the forces in the x will be, so this will be, you guys can see, this will be F1x plus F2x. And similarly, the Ry component of the resultant, we can say that that will be equal to the sum of the forces in the y, or we can say the sum of the component in the y. So we can say this will be F1y plus F2y. So we have to find, this is our equation 1, this is our equation 2. So we have to find F1x, F2x, F1y plus F2y, and we have to add them by, and that will be the vector addition. So as you guys can see that this F1 is making 30° with the positive x-axis, so it will have two components. One component will be in the positive x and another component will be in the positive y. So if this is our positive y direction, so one component is in the positive x, another component is in the positive y. So this will be F1x, this will be F1y. Now as you guys can see that F1x is adjacent to the angle 30°, then F1x will be the cos component. So we can say that, let me draw the free body diagram. So this is that point O, and we are having this 2 kilonewton force, which is F1. F1 is equal to 2 kilonewton. So it will have one component in the positive x. This one will be, this is 30°. So this F1x will be equal to F1 cos of 30°, because this component is adjacent to the angle. So we can say this will be 2 cos of 30° in kilonewton, and we will have one component in the y direction. So this one will be F1y, and this one will be the sine component. So we can say this will be 2 sine of 30° in kilonewton. So this is that point O where F1 is acting, and similarly we will have that 3 kilonewton force. So we will have this 3 kilonewton force here, and it will have two components as well. So it will have one component in this direction, and it will have one component in this direction. So this one will be, if this is F2 equals to 3 kilonewton, so this one will be F2 if we are considering this angle. Let's say if we are considering this angle, let's say this angle is theta. So then f2x will be the cos component and f2y will be the sine component. So we can say that f2x will be f2 3 cos of theta and f2y will be 3 sine of theta. So now we can say that our x will be equal to this f1x. So f1x is 2 cos of 30 kilonewton. So we can say 2 cos of 30 kilonewton, and this is acting in the positive x, so we must write positive here. So this is plus, and similarly f2x is acting in the positive x as well. So this is also plus, so we will write plus 3 cos of theta. Now if we are considering this angle theta, so we must consider the angle theta of the small triangle as well. So we are going to consider this angle. So for this angle theta, the cos will be the base divided by hypotenuse. So from that small triangle, cos of theta is 3 divided by 5. So this is 3 divided by 5. So our x is, you guys can see that our x is 2 cos of 30 kilonewton plus 3, or we can say 9 divided by 5. 3 into 3 is 9 divided by 5. So this gives me 3.532. So 3.532 kilonewton. 3.532 kilonewton. This is the Rx component of the resultant. And this is, you guys can see, this is plus sign. So this means that the Rx component of the resultant is in the positive x. Similarly, we can say that Ry is equal to the sum of the components in the y direction. So now this F1y is acting in the positive y direction. So this is positive. So we can say that F1y is plus 2 sine of 30 degree, and F2y is in the downward direction. This is our positive y direction. So F2y is in the downward direction. So this will be minus. So we can say minus 3 sine of theta, and sine of theta from this triangle will be, so if this is the theta, then sine of theta will be the perpendicular divided by hypotenuse. So that will be 4 divided by 5. So from this we can say that 2 sine of 30 minus 3 into 4 is 12 divided by 5. So this gives me minus 1.4. So minus 1.4 kilonewton. Minus 1.4 kilonewton. Now putting our x and our y, the scalar components, in this equation, we will have resultant vector which will be 3.532 in the positive I and minus 1.4 in the negative j. The units are in kilonewton. So this is the Cartesian vector representation of the resultant of these two forces, and then we are asked to find the angle of the resultant with the positive x-axis. Now we can show the resultant. So this means that the x component of the resultant is in the positive y direction, in the positive x direction, and the ry component is in the negative y direction. So we can say that this is the Rx component of the resultant, which is having a magnitude of 3.532 kilonewton, and the y component is in the downward direction. So we will have the y component in the downward direction. So this is the Ry, and the magnitude of this is 1.4 kilonewton. So, and this will be the sum of both of these components will be the resultant. So this is the resultant. And now we are asked to find the angle of the resultant with the positive x-axis. So the positive x-axis is going to be in this direction. So we are asked to find this angle, let's say angle alpha. So we are required to find this angle alpha. So now if I apply tan alpha to this right angle triangle, so tan alpha will be the perpendicular divided by the base. So we can say that tan alpha, which is equal to Ry divided by Rx, and Ry is 1.4 and Rx is 3.532. And similarly, we can find alpha, that will be equal to tan inverse 1.4 divided by 3.532. So we can say that tan inverse of 1.4 divided by 3.532, so which is equal to 21.62. So we can say that angle alpha is equal to 21.62 degrees, and the angle is with the positive x-axis but in the clockwise direction. So we must show this is the direction of the angle, so that is in the clockwise direction. So 21.62 degree angle the resultant is making with the positive x-axis. So this is one way of solving this problem, by finding by the summation of the x component and by the summation of the y component, and then taking tan alpha and finding the angle. Now another method of this question is by applying the geometrical method. So let me copy this. Now, as we know that if we add f1 and f2 by head to tail rule, they must give us the resultant. So if I apply the geometrical method, we can say that if this is, let's say, f1, this is, let's say, f1 and f2, let's say this is f2. So if we add f1 and f2 by head to tail rule, then we will get the resultant. So this will be the resultant of f1 and f2. So this will be that resultant which is required. So now as you guys can see that f1 is making 30 degree, this is given. So we can say that f1 is making 30 degree angle here. So we can say that f1 is making 30 degree angle here, and f2 is making some angle with the horizontal as well, and that angle is given in the shape of this small triangle. So we can say that f2 is making that same angle theta. Let's say this that angle theta, so we can say this angle theta, and we can find that angle theta by applying tan theta to this right angle triangle. So if this is that angle theta, this is that angle theta, and we can say that tan theta to that right angle triangle will be the perpendicular divided by the base, and we can say that theta is equal to tan inverse 4 divided by 3. So we can say that tan inverse 4 divided by 3 is 53.13. So theta is equal to 53.13. So f2 is making 53.13 degree angle with the negative x-axis. So we can say that this angle is 53.13. And similarly, if I draw a horizontal line here, then this angle and this angle, both of these angles will remain the same. Both of these angles are alternate angles. So we can say that if this is theta, then this is theta as well. So let me show that this angle is that angle theta, which is 53.13. And similarly, if I draw a horizontal line here, then this angle and this angle, this is 30 degree as well. So we can say that this angle is 30 degree as well. So we can find this angle. We can find angle alpha. So we can say that alpha plus 30 degree plus 53.13 degrees, this is equal to 180 degrees. And we can say that alpha is equal to 180 minus 30 minus 53.13. So this gives me 96.87 degrees. 96.87 degrees. So this angle alpha is 96.87 degrees. So let me show that this angle is 96.87 degrees. Now, as you guys can see, we know the magnitude of f1, we know the magnitude of f2. f2 is 3 kilonewton, f1 is 2 kilonewton, and we want to find the magnitude of the resultant. So you can apply law of cosines. So for law of cosines, we must know the magnitude of this, we must know the magnitude of this, and we must know the included angle between both of these f1 and f2. So So if we apply law of cosines, we can say that r square is equal to f1 square plus f2 square minus 2 f1 into f2 cos of the included angle, which is 96.87 degrees, and want to find the magnitude of the resultant, so we have to take the square root. So f1 is equal to 2 square, f2 is equal to 3 minus 2 into 3 cos of 96.87 degrees. Taking the square root, this will give us the resultant magnitude, which is equal to 3.799. So we can say that the resultant magnitude is equal to 3.799 kilonewton. Applying the Pythagoras theorem, so we can say that R magnitude will be equal to 3.532 square plus 1.4 square under the square root. So we can find that magnitude as well, and we can compare the answer from both the methods. So we can say 3.532 square plus 1.4 square, which is equal to 3.799. So the resultant magnitude from the first method was 3.799 kilonewton, and similarly from the second method, from the geometrical method, this is 3.799 kilonewton as well. Or we can say that the resultant magnitude is approximately equal to 3.80 kilonewton. So we determined the angle of the magnitude of the resultant by using the geometrical method. Now we can find our x and our y once we find the angle of the resultant with the positive x-axis. Now we have to find this angle beta or alpha, let's say. So let's say that the resultant is making some angle with the horizontal, and that angle is let's say alpha, or we can say let's say beta, because this angle was alpha. So we need to find angle beta. Now we can find angle beta if we apply the law of sines. So we can say that this whole angle for this triangle, we can consider this whole angle, and this whole angle will be 30 plus beta, and we want to find that beta. So if I apply law of sines, sine of 30 plus beta divided by the magnitude of the opposite side. So the opposite side to this 30 plus beta angle is f2, which is 3 kilonewton. So divided by 3 is equal to sine of this 96.87 divided by the resultant magnitude. So we can say sine of 96 divided by the magnitude of the resultant, which is 3.799. So if I cross multiply both sides of equation with 3, so we will have this will cancel out, and we will have sine of 30 plus beta is equal to this thing. So let's find 3 sine of 96.87 divided by 3.799, which is 0.784. Now if I take sine inverse of 0.784, you guys can see shift sine inverse of the answer is 51.62. 51.629 degrees. Now remember that the sine of the complementary angles is always equal. So if I subtract this angle 180 minus 51.629, let me find this angle, and then I will explain that what we need to do further, right? So 180 minus 51.629, this is equal to 128.371. Now the sine of 51.629 is equal to this, and sine of 128.371 is also equals to 0.784. So if we take sine inverse of this answer, 30 plus beta will either be equal to this or will be equal to this. So you guys can see, you guys can check that sine of 128.371 is equal to 0.784, and similarly sine of 51.629 is equal to 0.784. So now from this discussion we can say that 30 plus beta, we can say that 30 plus beta is equal to sine inverse of 0.784, and from this sine inverse of 0.784 is equal to this or this. So we can say that 30 plus beta is equal to 51.629 or 30 plus beta is equal to 128.371 degrees. Now from this we can say that beta is equal to 51.629 minus 30, and from this we can say that beta is equal to 128.371 minus 30. So 51.629 minus 30 is equal to 21.629 degrees, and similarly 128.371 minus 30 is equal to 98.37. So beta is equal to 98.37. Now if you guys look for this diagram, then you guys can see that this beta angle is less than 90 degrees, because if this beta angle is 98.371, then the resultant must be acting somewhat like this. If the resultant is acting like this, then this angle is 90 degrees. So if the angle is greater than 90 degree, then the resultant must be acting somewhat like this, which is not possible. So you guys can see that this is not the solution, this is the solution. So beta is equal to 21.629. So this means that the resultant is making 21.629 degrees with the positive x-axis. And from the previous method we got 21.62 degrees as well. So 21.629 degrees with the positive x-axis. So the resultant magnitude is 3.80 kilonewton, and it is making 21.629 degree angle with the positive x-axis. So this is the solution of this particular problem. You guys can solve. The easiest method is to use this method and to find the solution by using this method, and this method will always give you the resultant magnitude by finding the rx and ry components, and then by applying this formula you guys will be able to find the angle of the resultant. So this is the solution of this particular problem. I hope this will help. Do subscribe Engineers Academy for the solution of such more problems from Engineering Statics by Meriem and Kraige.